Welcome to my class. I'm Drew Collop. In today's class, we're going to continue talking about factoring. In our last class, we spoke about common factoring as well as difference of squares. Today, we're going to talk about factoring trinomials. Let's talk about what a trinomial is. A trinomial is a polynomial that has three terms. It has a second degree term, a first degree term, exponent of 1 there, and a constant. Notice there can be coefficients in front of both your first and your second degree term. We're going to represent this as capital A on your second degree term, capital B on your first degree term, and capital C as your constant. Don't worry, you don't need to memorize these for the future. Just for the beginning of the lecture, I'm going to be talking about A, B, and C. If our A is equal to 1, this is called a simple trinomial. The coefficient on your first term is 1. If that is the case, there's a very simple method to factor these trinomials. Let's look at that now. So remember, if we had x plus a and x plus b, if we were to distribute it, we would first distribute the x to those terms, and we would distribute the a to those terms. When we distribute it, we have x times x, we get x squared, and then we have x times b, which is going to be xb. Likewise, when we distribute the a, we have a times x, ax, and we have a times b, ab. What do you notice here? As you can see right here, the coefficient on our term is the sum of a and b. And our constant is the product of a and b. Right here and right here. So what we can do, we can use this and work backwards. If we're given something like this, we can factor it into that. Let me show you what I mean. Example 5a, I have a simple trinomial. How do I know that? Because the coefficient on my second degree term is 1. We then look at our other terms. Our first degree term, the coefficient is 8, and our constant, we have 15. So factoring a simple trinomial is quite simple. Find two numbers that multiply to your constant, 15, and those same two numbers should add up to your coefficient on your first degree term, in this case, to 8. What I normally do is I write it like this. I want two numbers that multiply to 15, and those same two numbers should add up to 8. So ask yourself, what multiplies to 15 and adds up to 8? This one should be pretty simple. However, it can get more challenging. What are two numbers that multiply to 15 and add up to 8? What I normally do is I try and take numbers that add up to the 8, and then I see if those numbers multiply to 15. So we have 1 plus 7 would be 8, but 1 times 7 is not 15. I then try something else. 3 plus 5 is 8. 3 times 5? Yes, that is 15. So the two numbers you're looking for are 3 and 5. Will they be positive or negative? Well, they will both be positive, right? We have positive 3 times positive 5 is positive 15, and positive 3 plus positive 5 is positive 8. Now that we have those two numbers, what we then do is we just break this up and we insert those numbers here. Positive 3, positive 5. Here and here. And we are done. So once again, when factoring a simple trinomial, you look for the same two numbers that multiply to your constant and add up to your coefficient on your first degree term. Let's try another one. So I want two numbers that multiply to negative 15, that negative is important, and add up to positive 2. What two numbers do we have there? Well, from before we said 15 was 5 times 3. We're still going to use 5 and 3, but in this case here, what you're going to do is you're going to put a negative on one of the terms. Which term is negative? If you look here, when we sum those up, we get a positive number. Therefore, the bigger number is a positive and the smaller number is a negative. 5 minus 3 is 2, and negative 3 times 5 is negative 15. Therefore, when we factor it, we get minus 3 plus 5. Again, it doesn't matter the order. I could switch those around. It means exactly the same thing. Let's try the next one. Two numbers that multiply to 3 and add up to negative 4. I'm going to guess 3 and 1. 3 times 1 is 3, but 3 plus 1 is not negative 4. So what do I have to do? Put a negative sign in front of both of them. Two negatives. Negative 3 times negative 1 is positive 3. Negative 3 plus negative 1 is negative 4. Therefore, we get x minus 3, x minus 1. What about this one? This one looks more challenging. Look right here. We have a coefficient on our first term, and our first term isn't even a second degree term, it's a third degree term. From our last lecture, what should you do when you factor? What's the first thing you should do? Remember, you should try and pull out a common factor first. Always, always, always see if you can common factor first. Let's take out a common factor from this. Let's examine our numbers here. I can pull out a common factor of 3. Let's examine our variables, x cubed, x squared, and x. So I can pull an x out of each of them. In the end, I pull out 3x. When I remove 3x from the 3x cubed, I get x squared. Remove the 3x from the 12x squared. 12 divided by 3 is going to be 4. 4x, and then remove 3x from 9x, we have plus 3 remaining. Now hopefully you can see, here we have a simple trinomial. Why is this a simple trinomial? Because our second degree term has a coefficient of 1. Let's now factor that. So I'm looking for two numbers that multiply to 3 and add up to negative 4. Don't forget the negative sign. We just did that one right here. So this will become 3x. Final answer. Notice when I said final answer, I included this here. Please do not remove this. Many a times I see students factor out a value like this, and then on the next line, it just disappears. Don't do that. If I just delete 3x from this expression, it changes the entire expression by 3x. So it must remain in there. So once again, when you're factoring a simple trinomial, that's a trinomial with a coefficient of 1 on your second degree term. You're looking for two numbers that multiply to your constant, the last number, and those same two numbers should add up to your coefficient on your second degree term. It's going to be your middle number. Once you do that, those become your values that come after your x. We have some practice questions here. You can see this is called practice 3. We're continuing on from the last lecture where we had practice 1 and 2. So here we have A through to H. Give those a try. I'll take some of them up. But just like last time, if you scroll down to the bottom of your page, you can see all the correct answers there at the end. So I'll take only some of them up. Give that a try now. Let's take up D. D looks challenging. Why? Because it's just out of order. Let's rearrange it. We'll put our second degree term first, then our first degree term, then our constant. Notice these things mean exactly the same thing. Remember, I said when working with a simple trinomial, your coefficient on your first degree term has to be 1. We don't have that here. We have -1. So we can factor out a -1 from all these. Put that outside the brackets and switch the sign on each of these terms inside the brackets. Now we have a simple trinomial. We're looking for two numbers that multiply to -8 and add up to -7. What two numbers do that? Well, we have 8 and we have 1. Notice here, when we add them together, we have a -7. Therefore, the negative sign has to be on the bigger value. So -8 plus 1 is -7. -8 times 1 is -8. We now factor this. Don't forget to leave that common factor outside the brackets. We have y here, y minus 8, y plus 1. Final answer. You could also write this as a negative sign outside, like that. So you can see sometimes you have to rearrange and pull out a common factor before you can use your techniques of factoring a simple trinomial. Let's take up f. Again, this doesn't look like it's a simple trinomial. Why? Because our first degree term is not a 1. But we can factor out a 5 from each of these. When we do that, 5 comes out, y squared plus 8y plus 12. Now we have a simple trinomial. Looking for two numbers that multiply to +12 and add up to 8. What are those two numbers going to be? 6 and 2. 6 times 2 is 12. 6 plus 2 is 8. This then gives me y plus 6, y plus 2. Again, remember to leave that common factor you took out. Don't delete it. Let's work through g together. Here we have x cubed, x squared, and x. This is not a simple trinomial because we have a third degree term there. No big deal. You can see we can pull out an x from each of these values. In doing that, x comes out, x squared plus 18x plus 72. Now I have a simple trinomial. Coefficient of 1 on my first degree term. Looking for two numbers that multiply to 72 and add up to 18. What I would do to find this is just in my head go through how to eliminate terms. So if we said 4 plus 14, that would be 18. 4 times 14, that would be 56. I would then go to 5. 5 plus 13 is 18, but 5 times 13 is 65. Also not correct. What's next? 6. 6 plus 12 is 18, and 6 times 12 is 72. So our two values are 6 and 12, both positive. This gives me x plus 6, and x plus 12. H is not challenging when you pull out a common factor. Again, I'm not taking any of these up. We have the final answer if you scroll down to the bottom of your page. If you have any difficulties with these, see me outside of class or ask me during tutorial. So that was how to factor a simple trinomial when our coefficient on our second degree term is 1. Let's now examine when that coefficient is not 1. This is called a complex trinomial, when the coefficient on your second degree term is not a 1. There's a bunch of rules here. It looks quite confusing. It's probably easier just to show you how to do it. There are trial and error methods to do this, but it does not show your work. There's also a strange method where I see students write numbers like this, and then they write that, and then magically the number appears, okay? You will get no marks for that. Why? Because you're not showing your work. I need to see what's called decomposition. What happens is we take that first degree term, that term in the middle, and we decompose it into two separate terms. So there's a whole process here. Just reading it off can be complex. Let me show you how it is, and then we'll go through the process together. So example 6, factor this complex trinomial. You can see this is a complex trinomial because our coefficient on our second degree term is not a 1. So again, we want to look for two numbers that multiply together and two numbers that add together. The two numbers that add together will still be 7. However, when we multiply together, what we're going to do is we're going to take both that value and multiply them together. This will be 6. This now becomes the value you want to multiply together. So here we're looking for two numbers that multiply to 6 and add up to 7. It's going to be 6 times 1. Now here is where things get quite a bit different from when we were factoring a simple trinomial. Let's look at the process here. All we've done in this process of decomposition is step number 1. We found two numbers that multiply to give you your coefficient on your second degree term multiplied by your constant, and we looked for those same two numbers that add up to b. We got those numbers being 6 and 1. Step number 2, we're going to decompose with these new coefficients. Let me show you what I mean. 6 and 1. 7x is decomposed into two separate terms. Which terms are they? 6x and 1x. You can see if I add these up, it gives me 7x. This remains the same, and this remains the same. So you can see we've decomposed that middle term into two separate terms. It also doesn't matter the order you put them in. You could have put 1x plus 6x. I'll show you that a bit later. So that's step number 2 and number 3. At this point, you should have 4 separate terms. What we're going to do is we're going to group the first two terms together and the last two terms together. And we'll pull out a common factor. So we're going to group the first two terms and the last two terms together. What's a common factor between these values? I have a 3 and an x. What's a common factor between these values? And there must always be a common factor that comes out. You don't see one here, but remember, you can always pull out a value of 1. We then pull that common factor out. 3x comes out of the first grouping, and we're left with x plus 2. We take a 1 out of this one, plus 1, and we're left with x plus 2. Do you see something there? If you've done it correctly, the values in brackets should be identical. Back up here, what remains inside the brackets should be identical in both groupings. We then pull these values out as a common factor. So you can see this is one big term and this is one big term. So what's my common factor between these terms? My common factor is x plus 2. I can pull that out now. X plus 2, 3x plus 1. Final answer. So this is how you factor a complex trinomial. When our coefficient on our second degree term is not a 1, we multiply the coefficient on the second degree term by the constant. We then look for two numbers that multiply to that new value, and those same two numbers should add up to the coefficient on the first degree term. These two numbers we get decompose that middle term, the first degree term. We then group the first two and the second two, pull out that common factor that should be identical between them, and we're done. I said earlier, it doesn't matter the order you put it in. Let me show you what I mean. 3x squared plus 1x plus 6x plus 2. So once again, you can see I've just switched those around from the other one. Group those together and group those together. On the next line, I pull out a common factor here. I'm going to pull out a common factor of x. Leaves me with 3x plus 1. Next, I pull out a common factor of 2, leaving me with 3x plus 1. Again, you can see we have exactly the same value inside those. We pull that as a common factor, 3x plus 1, and we have x plus 2. Exactly the same thing. So you can see when we decompose that middle term, it doesn't matter the order we put them in. If we follow the steps, we should get exactly the same answer. Before we move on, I want to show you something. Before, when we were factoring simple trinomials, we showed you that little interesting technique. Decomposition will also work for this. However, you do not need to show me your work, but let me show you what I mean. We're looking for two numbers that multiply to, again, if we were multiplying these together, 1 times 15 is 15, and those same two numbers would add up to 8. What two numbers multiply to 15 and add up to 8? It's going to be 3 and 5. Now before, when we were talking about simple trinomials, it was easy. I just wrote those down, and here was the final answer. That just seems to magically appear, and I don't like that when we're doing math. I like to show you where this comes from, not just magically some trick and you get the final answer. That being stated, on any assessment, you're welcome to do this for simple trinomials. However, for complex trinomials, I must see the decomposition. Let me now show you how this works for decomposition of a simple trinomial. So we decompose the 8x, we have 3x, and we have 5x. I put the 5x over here because I can see there's going to be a common factor 5 between my 5 and my 15. Over here, 1x. Group the first two and the last two together, pull out a common factor, x comes out, x plus 3, pull out a common factor here of 5, x plus 3. We now pull out this common factor, and we get x plus 3 times x plus 5. Same answer. So I wanted to show you why that previous technique for simple trinomials works, because in fact you're doing decomposition. Once again, for any simple trinomials, you do not need to show me your work. For simple trinomials, this is all the work I need to see. I need to see this, and I need to see this. For complex trinomials, you must show me decomposition. You must show me that middle term decomposes into two separate terms. Again, if you have some alternative method, I don't want that method. Why is that? Because you're not really understanding how the math works. You've found some sort of trick, and it's gotten you this far. However, when you move forward in math, if you don't understand what's going on behind the scenes, you'll have a hard time understanding future concepts. So please learn this concept. Let's try example 8 together. Here, this is a complex trinomial because I have a coefficient that is not 1 on my second degree term. So I'm looking for two numbers that multiply to 4 times 3, which is going to be 12, and the same two numbers should add up to 13. What two numbers multiply to 12 and add up to 13? Well, 12 and 1, we have negative 12, negative 1. Right? Negative 12 times negative 1 is positive 12. Negative 12 plus negative 1 is going to be negative 13. So I'm going to decompose this value into 12 and 1. 4x squared minus 12x minus 1x plus 3. I then group these together and these together, pull out a common factor. 4x comes out of the first groupings, leaving me with x minus 3. Out of the second grouping, I'm going to pull out a negative 1, x minus 3. That's another trick you can do. If you see what your first grouping is going to be, you can just make your second one the same value. You can see I just had to pull a negative sign out of both of those. In doing that, I then get x minus 3, and then I multiply that by 4x minus 1. So you can see this is the common factor, and what remains, 4x minus 1 right here. And we are done. Let's try B now. So B, I'm looking for two numbers that multiply. 2 times negative 6 is minus 12. And our coefficient on our first degree term is minus 1. What two terms multiply to negative 12 and add up to minus 1? It's going to be minus 4 and 3. We will then decompose that middle term into minus 4x plus 3x minus. Group these and group these, pull out a common factor. 2x, x minus 2, plus 3, x minus 2, giving me x minus 2, 2x plus 3. Now please note, it doesn't matter the order these come in. Quite often though, professors prefer it to be written like this, just so the larger coefficient is on the first value you see. I don't care. It means exactly the same thing. Let's try C. Looking for two numbers that multiply to 30, right? 2 times 15. And those same two numbers should add up to 11. What do we got there now? 6 and 5. 6 and 5. 6 plus 5 is 11. 6 times 5 is 30. So I'm going to decompose the 11 into 6 and 5. Group the first two, group the second two. Pull out a common factor. Pull out a common factor from the next grouping, 5. And then we have 2y plus 5 times y plus 3. Again, if you do it correctly, there's a check. You should have exactly the same values inside the brackets. If you don't get the same values, you've done something wrong. Stop. Don't go any further. Go back and correct. I would like you to try D on your own. I want you to see if you've learned what I've taught. Give this a try now. Let's take this up. So I'm looking for two numbers that multiply to, this is going to be difficult, 8 times 20. It's going to be 160. And I'm looking for two numbers that add up to give me minus 44. That's challenging. You can do that. It's not a big deal. However, remember what I said about factoring. What's the first thing you should do? To try and pull out a common factor first. Let's do that first. What's a common factor between all of these? I can pull out a 4. Now we have something a bit easier to work with. I'm looking for two numbers that multiply to 10 and add up to minus 11. Minus 10, minus 1. Decompose that center term. Group the first two and the second two terms and pull out a common factor. Notice the 4 remains with the expression. Pull a common factor of 5x out. X minus 2. Pull a common factor of minus 1 out. X minus 2. We have the same thing here and here. Therefore, we will get 4 times 5x minus 1 times x minus 2. Final answer. Again, do not remove that value. I don't know why, but sometimes students pull out a factor and then the next line they just remove it. No, that 4 has to be there. It's part of the expression. If you didn't see that initially, you could have still worked this out. It's going to be minus 40 and minus 4. You would then break it up 20x squared minus 40x minus 4x plus 8. This would give me 20x x minus 2. And here, take out a 4, x minus 2. Sorry, take out a minus 4. This then gives me 20x minus 4 and x minus 2. Pull out a common factor from both of those. 4, 5x minus 1, x minus 2. So you can see we get the same answer. It's just a bit more challenging when you're trying to find out those two values. But if it says factor completely, I need that 4 to be outside the brackets. We have a number of practice problems. But before we get there, I'm going to show you one additional thing. Decomposition also works if you have two variables in the expression. So I'm just going to look at the numbers here. Looking to multiply two numbers to get 35, and those same two numbers should add up to 20. What two numbers are those? Those are 7 and 5. I will then decompose that middle term into 7xy and 5xy. I will then group the first two and the second two. Pull out a common factor here of x plus 7y. Over here, we pull out a common factor of 5y, leaving me with x plus 7y. You can see it works exactly the same. We have the same value here and here. This then gives me x plus 5y multiplied by x plus 7y. So if you see you have an x and an x and a y and a y, you can decompose this using the same technique. If you want to double check, you could distribute your answer. You should get what the initial value was. I'd like you to try B right now on your own, then we'll take it up. Let's take it up. We're looking for two numbers that multiply to 6 and add up to 7. It's going to be 6 and 1, right? We're then going to decompose that middle term, 3x squared plus 6x. Oh, I forgot the y. Don't forget the y. 6xy plus 1xy plus 2y squared. Group the first two and the last two, pull out a common factor of 3x from the first grouping, x plus 2y. We're going to pull out a common factor here of just 1y, x plus 2y. Again, you can see if you've done it correctly, you should have exactly the same terms inside those brackets. 3x plus y, x plus 2y. Final answer. Once again, a large number of practice problems here, A through to G. So give this a try right now. Again, in the notes, the correct answers are at the bottom of the page. Try them now. I'll take some of them up. Those I don't take up and you have problems with, see me outside of class or ask me during tutorial. Give those a try now. Most of these are pretty easy if you know what you're doing. Let's take up F. F is more of a challenge. So here we have a complex trinomial. We have two different variables, so I'm looking for two numbers that multiply to minus 32 and two numbers that add up to 14. It's going to be 16 and minus 2. We will then decompose that middle term into minus 2pq plus 16pq minus 32q squared. Again, we're going to group the first two and the last two, pull out a common factor. Common factor from the first grouping is only a p. We have p minus 2q. Pull out a common factor from our second grouping. We'll take out a 16q plus 16q, leaving me with p minus 2q. Again, once we've done it correctly, we should see the exact same value there and there. And here we have p plus 16, p minus 2q. I guess that one wasn't very challenging. For D, there's two ways you could go about this. Let's do it both ways. What's the first thing we should always do? We should try and pull out a common factor. Pull a common factor of 2 out. M squared minus 2mn minus 3n squared. Looking for two numbers that multiply to minus 3 and add up to minus 2. Those two numbers will be minus 3 and positive 1. Let's now decompose that middle term. Remember to keep that coefficient of 2 you pulled out. M squared plus mn minus 3mn minus 3n squared. Group together the first two and the second two, pull out those common factors. Remember to keep that 2 in there. M comes out, m plus n minus 3n comes out, leave me with m plus n. Again, you can see a double check there. It looks like we've done it correct because we get the same value. This is equal to 2 times m minus 3n times m plus n. If you didn't see that, you could have also done two numbers that multiply to minus 12 and add up to minus 4. Those two numbers would be minus 6 and 2. We would just decompose this into 2 and minus 6. But in the end, remember, you'd have to pull out that common factor of 2. One final topic for today, substitution. Sometimes we can use strategies like substitution to make things easier. Here we have something that looks very challenging. X plus y squared plus 7 times x plus y minus 30. What we can do instead is we can substitute something in. Notice we have the same value here and here. So I'm going to let w, I don't know why I always use w as my substitution value, equal x plus y. When I do that, this becomes w squared plus 7w minus 30. You can see this is just a simple trinomial. So I'm looking for two numbers that multiply together to give me minus 30, and those same two numbers should add up to positive 7. What do we get there? We get 10 and 3, and that's going to be minus 3. So quite simply, because this is a simple trinomial, I can just write this as w plus 10, w minus 3. Are we done here? We are not. Don't forget to sub back in. W was a variable I made up. For the final answer, I have to sub back in what w is equal to. X plus y plus 10, x plus y minus 3. So you can see we took something that looked very challenging, and by substituting in a value, we could make it a lot easier. You will find this works a lot when you get to higher order math. Sometimes you look at it and it looks extremely difficult. And you can substitute something in to make it much easier. Let's look at another example. Here we have x to the 4 plus x squared minus 12. Previously, when our first degree term was not a second degree term, we were able to factor out a value. You can see we can't factor anything out here. But something I can do is I can say, let w equal x squared. How is that going to help me? Well, remember, what x to the 4 is just x squared squared. So here what I can do is everywhere there's an x squared, I can sub in my w. This gives me w squared plus w minus 12. Very simple. Two numbers that multiply to minus 12 and add up to positive 1. We're going to have 4 and minus 3. This gives me w plus 4 times w minus 3. Again, don't forget to sub back in your x squared. And if you wanted to, you could double check by doing FOIL and distributing. When you do that, you should get x to the 4 plus x squared minus 12. Look at this one. This one looks very challenging. Again, we can substitute. Let w equal to, what are we going to make w equal to in this case? I want that to be a second degree term. I want this to be a first degree term. So I can look at that, and I can say let w equal x to the 3a. How does this one relate to x to the 3a? Well, that's going to be x 3 to the a squared, right? When we take an exponent, we raise it to exponent. What do? We multiply them together. 3a times 2 is 6a. Just put a line between there so you don't get confused. So this becomes w squared plus 2w minus 3. Simple trinomial. Looking for two numbers that multiply to minus 3 and add up to positive 2. 3 and minus 1. This is going to be w minus 1. But remember, we don't want w as our final answer. We want x to the 3a in there. So hopefully you can see, by understanding many different techniques, you can solve these problems. Think of all these techniques as tools in your toolbox. The more techniques you know, the more tools you have to solve these problems. Here's some practice problems involving substitution. Give these a try. If you find these very challenging, the final answers are at the end. And if I don't take some of them up and you still have problems, contact me outside of class or ask me during tutorial. Let's just take up A. So here this looks challenging. What we'll do is we'll say let W equal x cubed. This gives me 3w squared minus 5w minus 2. Complex trinomial, I'm looking for two numbers that multiply to minus 6, right? 3 times negative 2. And those same two numbers should add up to negative 5. What two numbers are those? Minus 6 and 1. We now decompose that middle term. Pull a common factor from the first two and the second two separately. 3w, w minus 2. We take a 1 out here, w minus 2. Once again, you can see we've done it correctly because I have the same terms there. 3w plus 1, w minus 2. This is not our final answer. We want to remove the w and put back in what w was equal to. W was equal to x cubed. Now we have our final answer. So don't forget that. So when you're trying to factor an equation, the first thing you should do is you should try and look for a common factor first. Do that first, always. Next, see if it's a difference of squares. If it is, follow those rules. If you have 3 terms, check the second degree term. If it's a simple trinomial, you can factor it quite simply. If it's a complex trinomial, remember, decomposition is required on my assessments. If you have a term higher than 2, see if you can factor out or see if you can do a substitution. Finally, if you can't do anything else, I haven't taught you how to deal with it yet. I'm not going to teach you anything more than factoring second degree terms. Factoring third degree terms is not something that's part of this course. Now, honestly, factoring is not too important for the laboratory. What it is important for is for Math 273. So this section of factoring and quadratic equations is simply preparing you for your next course in mathematics. Again, you probably won't use much of this in the laboratory. Once we're done quadratic equations, the last part of the course will be only the mathematics of the laboratory. Before I've tried to allude how this is applicable to the lab, the last several lectures you will see definitely how it is applicable to the laboratory. That's all for today. Until next time.